For the final lesson in this chapter, lesson 17.6, we will be learning about the entropy changes in chemical reactions. So the standard change of entropy, which is the delta S of the reaction, keep in mind that Rxn is the same as reaction, is the entropy change for a reaction carried out at 1 atm and 25 degrees Celsius, which are standard conditions. The formula we use, say, take for example this chemical reaction, where A, B, C, and D are all different elements, or different components. We take the sum of the entropy value of the products multiplied by the number of their moles, minus the sum of the entropy values of the reactants multiplied by the number of their moles. So we will reach a formula similar to this one, where C is the number of moles and the capital S of C is the entropy value of element C. So in this question, they ask us to find the standard entropy change for the following reaction at 1 atm and 25 degrees Celsius. Knowing that these are the standard temperature and pressures, we can use the formula that we just took, which is the sum of the S values of the product multiplied by the number of moles minus the sum of the S value of the reactants multiplied by the number of moles. Usually in the test, we will be given the S values for each component. So all we have to do is input them into this equation. You will get 2 multiplied by the S value of CO2, which is 213.6, minus the sum of the 2 multiplied by the S value of CO, carbon monoxide, plus the S value of O2, which since it has no coefficient, we can just input that as is, which is 205. After inputting that into our calculator, we will find that the answer for delta S is equal to negative 173.6, and the unit here is joules per k mole. So what are the factors that decide entropy change in chemical reactions? Well, if a reaction produces more gas moles than it consumes, i.e. the reactants have less moles of gas than the product, the entropy will increase. If the total number of gas molecules diminishes, or reactants have more molecules of gas than the products, then the change in entropy will be negative. If there is no net change in the number of gas molecules, then delta S may be positive or negative depending on the S values of each component, but the change will be extremely small. Knowing this, the question asks, what is the sign of the entropy change for the following reaction? You have 2 zinc combining with 1 oxygen, resulting in 2 zinc oxide. Since we have O2 gas in the reactants, but no gases in the products, we can tell that the delta S is less than 0, or delta S is negative. The final thing we need to know about this chapter is the third law of thermodynamics. Third law of thermodynamics states that the entropy of a perfect crystal at 0 degrees Kelvin is always 0. We use this as a baseline for measuring all entropy values for other substances. And we can also infer from this that entropy rises with temperature.
That'll be it for lesson 17.6, entropy change in chemical reactions. If you have any questions or want to ask anything at all, you can ask it down below in the comment section or in the server. If you want any more tutorials or videos on the subjects such as physics, math, chemistry, and biology, you can find it in the channel, and yeah, enjoy them.